Hey everyone, today we're having a look at solving two-step equations. Okay, so when we solve equations, we're essentially looking for the value of the variable, the mystery number that's going to make our expression true. So in this example, 2 multiplied by our mystery number, add 4 will give us an answer of 14. So we're looking for what the value of a is that makes that expression true. Something that can help you when you think about this one is think of it in terms of what's happened to our variable. We've got our mystery number. It was then multiplied by 2 to give us 2 lots of the mystery number, 2a in this case. And then 4 was added onto it to give us 2a plus 4. And all of that is equal to 14. So what we can think about there is, well, if those were the things that happened to our variable, what we want to do now is try and reverse each of those things. So what I'll do to begin with is take away 4 from both sides of the expression. On the left-hand side, 4 take away 4 is going to just be nothing, which is going to leave me with 2a. On the right-hand side, 14 take away 4 is 10. Okay, now what I want to do is say, well, if my number has been multiplied by 2 to give me 10, the opposite step to that would be to divide by 2. And that's going to leave me with the value of my mystery number. So 2a divided by 2 is just a on its own, and 10 divided by 2 is equal to 5. Now you might look at this and think, well, it's 2 times a number plus 4 equals 14, and you can figure out in your head, well, if you add 4 and it gives you 14, then 2 lots of it's going to give you 10, so 1 of it has to be, 5. That is absolutely true, but for a lot of these sorts of questions, the way that they're marked is that you have to show each of your steps. So 1 mark for getting step 1 correct, 1 mark for step 2. If you were to just say a equals 5 as your answer, it's likely that you get the mark for getting the question right, but not the mark for showing all of your working. So following these steps is really important. Okay, we've got a couple of these to practice with. So first example here is 3b plus 5 equals 11. So I'm going to think about what's happened to my mystery number here. It's been multiplied by 3, it's had 5 added to it, and it's given me 11. So what I'll do, I'll take away 5 from both sides. And these little arrows that I'm drawing on the left and right, by the way, you don't have to show this in your working out, but it's a good way to visualize what's actually happening as I go from step to step. So on the left-hand side, 3b plus 5, take away 5, gives me just 3b on its own. On the right-hand side, 11 take away 5 will give me 6. So that leaves me with 3b equals 6. Now I'm going to do the opposite of multiplying by 3, which is to divide by 3, which makes sense. If 3 lots of my mystery number is 6, I need to divide 6 by 3 to figure out what that is, which is 2. So now what you can do as well is you can put this 2 into the equation here. The arrow's a bit dodgy, but essentially I can say, well, 3 multiplied by 2 is 6 plus 5 does give me 11. And if the expression is true, if you get an answer which makes the left and right hand side the same, then you know that you're on to a pretty good ticket in terms of a correct answer. Okay, this one, we've got 4 multiplied by a, take away 3 equals 17. So I'm going to have to reverse each of those steps. What I'll do first is think, well, 4's been multiplied, so a's been multiplied by 4, and then 3 was taken away. So I need to reverse that last step by adding 3. On the left-hand side, that will give me 4a. On the right-hand side, that will give me 20. Now I need to do the opposite of multiplying by 4, which is to divide by 4, which will give me 5. Okay, beautiful. And again, you can put this back into the equation to check if you want to. 4 multiplied by 5 is 20. Take away 3 is 17. Awesome. Okay, this next one's a little bit different. So for this one, we started with c. 2 was added to it to give me c plus 2. And then it was divided by 3 to give me c plus 2 over 3. Don't be put off by the fraction for this one. Remember, a fraction just means divide, so don't stress about that being there. It does make it look a little bit more scary, but we can handle it. Okay, first I'm going to do is the opposite of dividing by 3, which is to multiply by 3. Now, on the left-hand side, that's going to just leave me with c plus 2. On the right-hand side, I'm going to have 3 multiplied by 3, which gives me 9. Now I want to do the opposite of adding 2, which is to take away 2. So you'll see how I'm just sort of chipping away at this from both sides. And it will be left with c is equal to 7. The same deal again, you can put this number back in the equation to make sure it works. 7 plus 2 is 9, and 9 divided by 3 is equal to 3. So it looks like we're on to a winner. And last example, so for this one, we've started with b. It was multiplied by 3 to give me 3b. It was then divided by 2 to give me 3b over 2. The funny thing about this one is because everything in the expression is, there's no additions in there, it's all part of one thing. You could actually do this a slightly different way and say b divided by 2 gives me b over 2, and then multiplied by 3 gives me 3b over 2. So this one's a little bit different because we don't have the same addition and subtraction that we have to account for like we did in the other ones that we did before. But anyway, I'll use my first sort of flow chart here. I'll do the reverse of that. Dividing by 2, opposite action is to multiply by 2. So on the right hand side, 3b divided by 2 multiplied by 2 will just leave me with 3b. 6 multiplied by 2 is 12. Now I want to do the opposite of multiplying by b, which is to, multiplying by 3, which is to divide by 3. Right hand side leaves me with b, left hand side leaves me with b. On the right hand side, that gives me 4. So again, do the same thing again. 3 times 4 gives you 12, divided by 2 gives you 6. So you can check your answers correct like that. Lovely, thank you.